Hi guys, welcome to Origins Computer Classes once again. Hope you are doing well, right? See, in our previous lecture, we have already completed lecture on arrays, right? So, what were arrays? Let us give a bit revision. See, arrays were like it was also a variable, but a single variable could store multiple elements, right? Just a way a single variable has only one slot, and if I write int a is equal to 10, it can only store one value. But this is not the case with arrays. Arrays can store multiple values of the same data type, right? If I talk about Java, in case of Java, the declaration is like int a is equal to new int, and then the size you mention here, right? The number of slots it is going to have. Okay, and so hence a will be having these slots. Say this is the array. Okay, so I need to give an array bracket here. Fine, you can place it after the data type or also after the variable name. No issues in that. So this will be the array will look like this: 1 2 3 4 5, right? So this is an array. This variable has a capacity to store 5 elements together, right, in different slots indexed with 0 1 2 3 and 4, right? And the very important point is that it can only store elements of integer data type. I mean, if I store here 10, it is okay. 10 15, it is okay. But if I store here say 2.0, this is not done. I mean, this is not acceptable by the compiler. So these are the points. Please watch my, if you haven't watched my lecture on arrays, please search arrays part 1 by Origins Computer Classes, you will get it. Okay, in today's lecture we will be discussing what are 2D arrays. 2D arrays. See, now 2D arrays, by the name you get the thing, see, right? 2D means two dimensional. In maths, you have mostly seen 2D arrays, I will say, because 2D arrays are matrices basically. Okay, see, by the name what we get, the array should be having two dimensions. An array, see, imagine, till now we have learned a single dimensional array. A single dimensional array follows only one direction. Yes or no? Yes or no? A single dimensional array is following a one direction only, right? And say this along x, any axis, be it any axis x y z, but it is following that axis only. Now if I want to make it two dimensional, what will it be? Obviously it will be a matrix. See, if I consider an array like this, vertical one, and then here also another cells. Can't I call this a 2D array? This is what you can say. This is a 1 2 3 4 4 columns and 4 rows. So 4 rows into 4 columns is a 4 cross 4 matrix in simple term, right? A 4 cross 4 matrix. We have other ways to look at it. See, can I consider this single part to be an array? See, if this portion, if I consider this portion to be a 1D array, right? So if this is a 1D array having these slots, can I say like this, that from index 0 of this vertical array that I have marked with black, at index 0 of this vertical array, this array continues? Yes or no? This is an array. At index 1 of this array, at index 1 of this array, this is another array. Yes. Similarly at index 2 and the same at index 3. Fine. So see, there is another way to look at a matrix. Alright. And similarly, these individual arrays, these are actually, see, if I consider it a matrix, they are 4 cross 4 matrix, and I can index as 0, 1, 2, 3, and similarly here 0, 1, 2, 3. But see, what is the in-depth concept behind it? Actually, see, this is an array of array. An array of arrays. An array of arrays. This is an array of all these arrays. Can I say that? Can I say that? Absolutely yes. Because see, this array is at index 0 is having one array, and this array, this particular array is having having indexes 0, 1, 2, 3. Right? Yes or no? Got my point. So this is how we represent a 2D array basically. Right? Now, how to declare a 2D array? If I want to declare a 2D array, see, the syntax is very easy. Once you get it, you will be able to understand. See, in Java, if I talk about Java, see how we used to declare a single array and 1D array. Say this was a 1D array. This is a 1D array. I used to write int array bracket, then a is equal to new int and the number of slots. As there are 5 slots, 1, 2, 3, 4, 5. So 5 is the size of the array. If I talk about 2D arrays, it's an array of arrays. So see, int array bracket. Fine. This for, see, say for this array I have declared an array bracket. I am declaring this array, so one array bracket. Now inside this, see, this was an integer array containing integer values, integer elements. Yes or no? Integer elements. Here what I am saying is, this is an integer array and it is going to contain arrays. This is an integer array and it is going to contain arrays of integer type. Int we have already mentioned, so of course this array can contain integer types only. So that means it will contain array of integer data types. I am explaining again, wait. So another array bracket. Repeating it again. See, this is an array, right? This is a vertical array and all the cells are having individual arrays. Yes or no? So first time I am again erasing this, okay? See, first I am declaring this array. Okay? So int array bracket. Fine. Now I am saying, see, what I am saying is this array, this particular array, this I have already said this is an integer array. Fine. This particular integer array is going to contain arrays, right? Again arrays. So I am declaring, I have to declare arrays inside each cells of these. Yes or no? So therefore another array bracket. These arrays represent these individual array cells. Fine. Absolutely, this is the concept. These individual arrays. Wait. Right. So another array bracket, and then give the variable name, say A be the array name, or capital A, because I have already taken for another one the array, right? Capital A. Now the same thing, absolutely same, nothing is there. You are declaring a new, see, I have already told in my previous lecture, whenever you are calling an int and declaring an array, in Java array is like an object only, another object. Every variable is in fact like an object only, but also an array, right? Therefore, what today we are declaring new object of the integer class, so new keyword int. Now you have to pass the size. You have to pass the size. So now what is the size of this array? What is the size of this array? 4. What will be the size of the individual arrays? Here, so 4. That is why here 4. Got my point? See, in short you can write, here we write the number of rows and the number of columns, right? The size of rows, how many rows it is going to contain and how many columns it is going to contain, right? So this is how we represent a 2D array. Wait, so let me show a few examples how to declare it. You will understand it better. Let me take a few other examples. So I am taking a 3x4 matrix, okay? Okay, let me give you 5. Now, so see these images and try to tell me the syntaxes in case of Java. And also the C programmers also please try to think, because see, it is nothing, just in case of single dimensional array, what we used to do in case of single dimensional array, say an array of 5, size 5, we used to, in case of C program, we used to directly declare int A of 5. So in case of 2D array, what will it be? If I am taking a 5x5 matrix, so it will be like say 5 and 5, right? In the same way. So guys, pause the video for a while and think about what will be the syntaxes to declare these arrays in Java, Java programmers in Java and C programmers in C, right? So ready? Okay, so let us see. See, in Java, if I talk about the first one, in Java, the trick is what I told you, just take the number of rows and the number of columns. So as it is a 2D array, it will be 2 brackets, fine, and it is not necessary you need to take integer data type only. That depends on the question. That depends on the question or the program, what interviewer, whatever they ask you, depends on that. This is a data type, for example, I am taking, and say I am mentioning A as a variable name, new, right, to create a new object, and int. So what are the number of rows I stated? 3. And the number of columns? 4. As simple as that. In case of C, in C, if I talk about C, what will it be? In C it is much more simple, right? In C it is much more simple. So it will be int A 3 4, right? Yes or no? Let us come to question number 2. So again say some data type, then A, I am taking B for this now, is equal to new int 3 2. This is in Java. In Java I can say this is the way. And in case of C, what can we syntax? In C, int b 3 2. Fine. This will be like third one, and this is the fourth one. Okay, this is 3 cross 4 again. I have already given 3 cross 4. Okay, don't need to write this. Let me repeat it. Repeating question, same repeating question. So 3, how can it be written in Java? In Java, int a, say C, array bracket is equal to new int 3, 3, right? And in C, in case of C, it will be int C 3, 3. Right? So this is the way of declaring the arrays in Java and in C. Now you may be getting confused that, see, here I have taken the square brackets before declaring the variable, while here I am taking it after declaring the variable. So it doesn't matter. It's a square bracket you can take before variable, but if you are taking before the variable, it should be nearest to the data type without any blank spaces, just like I have done here, right? And then space, then the variable name. Fine. And here it should be int the in case of if I am declaring after the variable, so then the variable name, then the square brackets. So it doesn't matter how you, these square brackets represent the array. That's all. Fine. A 2D array. 2 square brackets, 2D array. 1 square bracket, 1D array. As simple as that. Right? Therefore, if I briefly discuss the syntax again, so the syntax of declaring 2D array is it is the data type, right? Either the variable name, then square brackets. So this is in case of Java. Okay, in case of Java is equal to new data type R C, where R is the number of rows, C is the number of columns. Fine. R is the number of rows, C is the number of columns, right? And or you can just keep the square brackets here also after the data type. So data type, square brackets, variable name. Fine. Better let me write the array name. This will be array name. See, arrays are also, these are also variables only, but as we are taking arrays, so array is the best term to use. Array name is equal to new data type RC. Fine. Is equal to new data type RC. Fine. And in case of C, it is as simple as data type, array name RC. So let me draw a line here to make a difference. So this is the Java syntax, and this is in below. We have the C syntax of C. Right? You can take a screenshot of this or note it down, whatever you wish. Now, let us see some basic programs. So how to take input into D array and all. Then there are programs like multiplication of two matrices, right? Any question related to the matrices belongs to 2D array, right? Because we have to matrix means we need to solve it using 2D arrays only. As you can see, I have seen as per the structure. Before that, let me come to the internal memory representation, a bit about the memory representation. See, in case of 1D arrays, the memory, in the memory, it is represented in the form of a long strip, as I have shown you, a contiguous allocation, right? So in case of 2D arrays, if I am drawing this the structure of a 2D array, 3 cells and 3 columns, 3 rows and 3 columns, fine. Say this is a memory cell. This is a memory cell. Let me draw it a bit bigger. 1, 2, 1. Because see, this is also an array, and similarly here 0, 1, 2. Now guys, what do you think? See, there are memory addresses to represent it. So if this is an integer type, the first cell will be 100 of address 100, right? There are two ways of representing 2D arrays in the memory. One is row measure, second is column measure. Okay, so this is 100, then 104, then 108, 112, right? 116, 120, 124, 128, 132, right? So here you can say the row wise, see the columns 100, then 104, then 108, the values are increasing in this direction, right? So see, in here if I talk about each cells, these are memory addresses. We can say this is a way something is stored in memories. As you know, actually the integer takes 4 bytes, right? So after 100 we have 101, then 102 and so on. I am considering for better understanding, presently I am considering these to be 1 byte, okay? Or let me draw it in a better way. Considering this entire to be 1 byte, to be 1 byte. This saving 100, okay, and enter this thing, say suppose up to here it is taking 100 to 103, then the new block is starting from 104. Here there are 4 bytes from 100, this is 101 say, okay, this 102, we have 101, 102, 103 and so on. Similarly for all the blocks. So every block is going to take 4 bytes, right? So 104, then this is going to start from 108 and say so on. So see, row measure means row wise in a particular row the values are increasing, right? Basically what is happening, this is called row measure representation, row measure. Now can I say from 100 to 112. Okay, 100, 104, 108. 0, 1, 2. Next row is starting directly from 112. Right? So basically, see 100, 104 and 100, this is covering row 0. Yes or no? 100, 104, 108, this is covering row 0. And inside each of these, each individual bytes are the columns. Can I say that? See 100, the base address of this is 100, and so this is column 0, index 0, our column 0, column. These are the columns. Okay. Again, this is starting from 104, this is 1, 108, and this is row. Fine. Yes or no? So again, from see this to this the gap is 12 bytes. This to this the gap is 12 bytes. And here to here it is 4 bytes. And here to here it is 4 bytes. So in row major representation in the memory, this is representation in the memory. Memory follows two ways to represent 2D arrays, because see, this structure of matrix is actually our imagination. Okay, but memory doesn't have this 2D structure, so it has a long band only. It has to do everything within this long band only. Therefore, it follows two orders, row major and column major. So it will consider as if these 3 blocks, this 4 byte of 4 bytes of 3 blocks. Okay, 3 blocks each of 4 bytes is a single row. Again another 3 blocks each of 4 bytes is in another block, another row. Fine. This is say row 1, row 1, row 1, and this starts from where? 112, right? Then 116, fine, 4 bytes, and 120. Fine. That means we can say the number of, in case of row major, the gap, the byte gap between two rows is the number of the gap between two rows, we can say is number of rows into size of data type. Can I say that this is a gap between two rows? Gap between two rows. Yes or no? See properly. It is 100, then it is 112, then 124. 104, 116, 128. 108, 120, 132. 12 bytes, 12 bytes, 12 bytes, 12 bytes. Here it is 4 bytes. So see, this is, can I say what? How many rows we have? 3. 3 into size of data type. Int is 4. Size of int is 4. So 3 into 4. This is 12 bytes. And in here it is 4. Here it is 4. So size of the gap between columns are size of data type. Size of data type. Right. So that means, another way, if you want to get a feel, row 0 is forming an array of columns. These columns are, as I have told you, basically in row major is following the same concept. It is considering these all kinds, this is an array, and all the rows are starting, see 0 is starting here, index 0 is making a row of this array. Yes or no? this array 0 1 2, this is an array 0 1 2 column, again 1. So this is what row major representation is. Row 1, this is another array. Row 1, this is another array. Fine. Now column, there another one is column major representation. Column major representation. Column major representation. If I talk about column major representation, see, in row major, what we are thinking, what we are imagining is that a row is, there is a vertical array, right? And as if all the rows are and forming an array of columns. Yes or no? Row is an array and it is forming an array of columns. Yes or no? That is what it is inside one row we are having. In column major, of course, the same opposite thing. Absolutely the opposite thing. We will be considering column as an array and as if inside them the rows are there. See, this is an array. 1, 2, and say this is this. There are 3 columns. So this is 100 now. This is 104. This is 108, 112, 116, 120, 124, 128, 132. That means this is say R 0 1 2 0 1 2. Now just you can see the gap between two columns are are number of columns or you can say number of rows. Here it is C, number of rows and columns are same. That is why you can take anything. If there is a if the number of rows and columns are different, that I will make another video where I will be in depth. I will be discussing about this. This is just a basic concept where I will be discussing the in-depth concept about the row major and column major and all its calculations. Okay. For now, consider whatever the number of rows. Let me take order of matrix, or no, number of rows. Say number of rows or columns, anything, or you can take columns. Okay, into size of data type and gap between rows is size of data type. Fine. And so therefore this is column 0 and inside this column 0, see, this is starting as row 1, I mean row 0. This entire thing is R0. This entire thing is R1. This entire thing is R2. Fine. So this is how it is a memory representation, just to give you a basic idea. This is the two ways it stores, the 2D array is stored in the memory. Fine. So I will be discussing in-depth concepts about this in my upcoming lecture. Just to give you a basic idea, this is how it is stored in the memory. Now, in the last thing for today, let us do a basic program related to 2D array. Just nothing that you need to take some certain input from user in the 2D array and you need to represent it in the form of a matrix. Okay. So let me write the program. As you know, I am taking a function, say, called input. It will be accepting a 2D array. Fine. From the main function. Okay. And I am declaring an array, say int arr is equal to new int I am taking a 3x3 matrix. Okay. Now, so if I am making a 3x3 matrix, in case of Java, I need to take the scanner class object. Scanner sc is equal to new scanner system.in system.in. These things I hope you know because you have watched my previous lectures on array and Java. So better let me write pseudocode which will be applicable for all the languages Java, C and Python. So whatever be the variable, I need to print one message in here that enter size or say enter elements fine. And just now take the how you take the input. See, if I am declaring 3x3 array in Java, in place of this print, what will I get? System.out.println. And in case of C, I am also writing this beside. In case of Java, I will be writing system.out.println in place of this print statement. In case of C, I will be writing printf. Fine, printf and inside this. Okay. Now, say this is my array, 2D array. 0, 1, 2. These are the indexes. 0, 1, 2 indexing. Now I need to first I need to travel this array, and what do I need to say? Index 0 of this array. I need to first come to index 0 of this array, and then when I enter this, I can travel this array. Same for the another index. So for traveling this vertical array, I need one loop. So I am taking one loop. Wait, R C, say int R is equal to 3, C is equal to 3. Int I is equal to 0, I less than R, I plus plus. This loop will be traveling this array. I mean, it will be traveling all the rows one by one. Yes, so this I loop will be traveling, hitting the rows one by one. First 0, then 1, then 2. Now, what I need, when it is hitting this 0, row 0, it should visit column 0, column 1 and column 2. Yes or no? It should visit this column 0, column 1 and column 2. So to visit all these, I definitely need another loop, because see, I am covering it up. I am in the row 0. This is this is another 1D array. Can I say that? In row 0, I am having one 1D array like this. So how to travel in any 1D array? Obviously using a loop. So inside this, I need another loop for int j is equal to 0. This is called nested loop, what we say. I am redrawing the diagram here. Zero, 1, 2, 0, 1, 2. Fine. J is equal to 0, j less than c, j plus plus, opening brace. Fine. So this is, I am hitting it, and now you can visit, you can take the input. Now, when I am taking the input, this is a hack in 2D array. See, this cell, this is in this cell, if I call it, this is in row 0 and column 0. Fine. So when I'm taking this input, I need to say A of 0. That means, sorry, ARR of 0. When I'm saying ARR of 0, ARR of 0, the first bracket represents what? The first bracket represents row, right? This array, this green array. So the first bracket represents this green sized array. So in the green array, in this green array, I am pointing to 0. That means I am pointing here. As simple as that. Fine. Right? If I am pointing here, I am already in this array. In this array. Yes or no? I am pointing in the 0, index 0 of this green array. That means I am already in this array. Yes or no? So now that means this bracket is for this array, indexes in this array, right? So say suppose I want to take input in 0, this cell only. So see, this is row 0 and in column 0. So this cell will, right? If it is column, this for this cell it will be 0 1, right? That means, so instead of writing directly 0 0, can I write here I for the row, for the j, and I am taking the input here. Now this input will be sc dot next int in case of Java, and scanf in case of C. Scanf in case of C. SC is any object of the scanner class. You can take any name. Okay. SC is just I am considering an object of the scanner class. Okay. Fine. In case of Java, and this is in case of C. Okay. Just note it now. So see how it works. Say when I is 0. When I is 0, I am closing. Now everything is done. And closing of this function also, input function. Fine. So when I am see, when I is 0, say I is also 0, it enters the j loop. Now you know that when until and unless this j loop become false, it will never go to the external loop. Fine. So this is the concept you know already. So when I becomes 0, right? It hits, I represents the row, index of this array, green array, right? So when I becomes 0, it represents the 0th index of this green array, Getting my point? Of this green array, right? And j is also 0. J represents the index of these arrays. That means basically you can say j represents the columns, as simple as that. J represents the columns, indexes of the columns. Fine. So when I am entering this 0, I am already in this array, right? Now I am saying j is also 0. That means j is pointing here. See, j is pointing here, I is pointing here. This is the cell. Yes or no? I is pointing here, j is pointing here. So this is the cell 0 0. Fine. And so you take some input. Say I am taking 50. Whatever be it, whatever user gives. Similarly, when j turns out to be 1, so say I is 0. When till the time I is 0, it hits in the 0th index of this green array, fine, and j is 1, so this means it points here, right? Basically, see, now you can understand it very clearly. It can be seen that this is 0 0, this is 0 1, j index of j is 0 2, and from here it again starts 1 0, 1 1 1 2 in this way. Say after 50 I take 60 here. Similarly, when j turns out to be 2, means it will represent 0 2, 0 index of this green array and 2 index 2 of this, right? So just simply note out this cell represents 0 0 0 1 0 2 and so on. It will be continuing like this 1 0 1 1. So row number 1, column number 0, row number 1, column number 1, row number 1, column number 2, right? This first place represents the row value, second place represents the column value. Fine, as simple as that. And when j turns out to be 3, when j turns out to be 2, say here it is 70, and when j turns out to be 3, now see, I is 0, fine, it enters this array already. J is 3 now, j is 3 now. Where is j pointing? J is pointing somewhere here. And 3 less than 3, c, value of c is 3. So 3 less than 3, it is false. It will not go to this task. It will go to I loop again. I loop will increase by 1 again. And see, as I loop again increases by 1, so j loop again begins from 0 only. So j will again start from 0. So 1 0 1 1 1 2. In this way, it will be taking inputs in the 2D array. Fine. Now let us come to the display part. So this is the function I am writing for display here. This is a display function and display function. So there is nothing new. It will also travel the array in the same way, same fashion. But just the thing is that it will print it in the matrix fashion. Because see, ultimately in memory, this is in the form of 1D array, right? So we need to manage something in order to make it print in the form of matrix fashion. What I am doing, see, whenever I is 0, j can be 0. When I is 0 and j is 0, it is pointing to 0 0 and 0 0, print error of I, so 50 gets printed. Fine. When it is 0, I is 0 and j is 1, it is pointing to 0 and 1, so what happens? 0 1, so 60 gets printed with a space. This represents a space. 70, this is 2, okay, j turns out to be 2, 70 gets printed. Fine. Now the thing is that you may be thinking, why have I written the println here? See, this println represents system.out.println in Java, and printf you can say /n in C, okay? And print is system.out.print in Java, not ln, not println. System.out.print in Java, and same, not just printf space in C, okay? So that depends on your programming language, whatever you are using. In Python it is something different, okay? Just the thing is that, understand, you need to print a new line. See, because a new row should start from a new line. This row has ended, here it should start from a new line. So to bring your cursor to a new line, the next line, this println works. So this println brings your cursor to the next line, and again it will be like I automatically turns out to be 1 after this, and j starts from 0, so 1 0 means 80, 1 1 is 90, this is 100, and so on, okay? And in this way everything will be printed 110, 120, 130. Fine. 1 0 80, 1 1 for 90, see 1, and this is 190, 1 and then 2, it will print 100, right? If I don't give this println, so this is your assignment. Just see, don't give this println function in Java. Don't give system.out.println here, and see what will be your output. Just see, just match with my output. It will be something like 50. If I am not wrong, it will be, you will be getting an output like 50, 60, 70, right? And then you will be getting 80 in the same line. You will be getting 80, 90, 100. So it will not be printed in a matrix fashion, rather it will be printed the same like an array, same like a single dimensional array. Fine. So that was all about today's lecture. In the next lecture, we will be discussing some more programs related to 2D arrays and also 1D array, and and also an elaborated, I will illustrate about the row measure and column measure representation in memory. Fine. So thank you. Take care. Take care of your family.